Right, up to say we can actually see that. Okay, that should be full screen. You seeing that, Matt?
Yeah, that's all good. Got a few thumbs up, hands up as well, so that's all good to go.
Great stuff. Excellent. Right, we'll crack on. Thank you all for coming today and having a listen to me rabbit on about structural repairs, something I'm sure you will all be fairly familiar with. But we want to, we call it the art of structural repairs because quite often there's a little bit more to it. It's not just the aesthetics, it's using unusual materials sometimes to get the problem solved. And that's really what I want to talk about today. That's myself. I'm the MD, and Stress UK has been going for over 30 years now, and we are a little group of companies. Here we go. I've had this problem before. All right, bear with me. I'll rub it on a little bit. We just suddenly get this where it decides that it doesn't want to. All right. It's a really weird thing. Okay. Yeah, just going on from where I was. Stress was a company that was set up over 30 years ago, and it really specializes in the repair and refurbishment of any type of structure, from a domestic house through to commercial buildings, a lot of listed building work, monuments, churches, other things that we deal with. But about in 2012, we were approached by Helifix, a company you've probably heard of. We're an approved installer of Helifix, who basically had tried to get a bridge company going, a bridge strengthening company going. And I had warned them that they may find it slightly different to selling products, which they did, and said, "You were right, Dave. Would you take the company over?" So we looked at it and we said, yes, we would. And that is Goldhawk Bridge Restoration. And that basically strengthens masonry arch bridges and masonry arches. So anything that you've got in the way of vaults, under streets, under houses, that sort of thing, arched masonry structures, we have a unique system for designing, strengthening systems and installing them. Due Innovations is our intellectual rights company. We do R&D into geotechnics, systems for strengthening the ground. And then if we produce anything, we then license that back to the main group to carry out in the field. So we have a number of different groups within the company. We do a lot of insurance work for subsidence, structural repair, but we'll literally repair anything from a palace down to a 2 up, 2 down. So that's us. We've been around, repeating some of the things that I've said. I don't know if those of you have ever heard of ASUC, Association of Underpinning Contractors. We have been a member of ASUC for probably nearly 20 years now. And that just gives a level of competence to carrying out underpinning and basement construction. The reinforced permeation engineering is one of the systems that we've got for polymer injection. You've probably heard it generally through the network at the moment. It is being misrepresented by a couple of naughty companies. It isn't the panacea for all problems, even though they say it is. But if you carefully use it, it's brilliant. Heritage repairs, love any old structures, fantastic. Listed building works, we actually carry out design and access statements. So we have a conservator within our group, and Annie will be able to help anybody make sure they don't transgress the law when it comes down to dealing with listed buildings. We love doing that too. But the thing that, and you'll see this coming up, we love unusual, awkward and high value projects. So that's the sort of thing that we love getting our teeth into, finding some way round a problem. Structural repairs, you'll have seen all that, just kind of run through all that. So I think we can't deny that that is a fairly typical, quite bad crack in brickwork. A typical thing that you would see when it comes down to generally subsidence, shrinkage of clays, sometimes washout of non-cohesive deposits, and that's what you'd see. So if you do, obviously as engineers, surveyors, you want to know what's causing it, because there's no point repairing something unless you know what's caused it and has that been dealt with. So we've got to find the cause. So you probably see in this particular instance, the cause was some fairly enthusiastic parking and the damage it's caused. Now, I'll put that up for two reasons. One, I know it was a serious incident, but it's actually quite amusing. The other is that, in fact, we get involved, or insurers involve us quite a lot in pulling their vehicles out of buildings, because there is a structural consideration that's got to be given to that. How much support is that car now giving that house? So you can't just pull the car out. You'll get additional and progressive collapse potentially. So we look at the structure, strengthen it if we need to, put temporary supports in as necessary to be able to pull that car out safely. Those are the sorts of things that we get involved with. Now, when you carry out any structural enhancement, repair of any sort, you're likely to cause some form of scarring to the building. So really, we all, if we have, or we are property owners, wouldn't want to be able to see that there's a big structural repair has been carried out to our house. We'd rather see that it's all contained within an aesthetic considerance. And so disguising the repairs, using techniques to make sure that you don't scar the building is really important. And if you're going to use helibar, how much do you use? Don't use too much. Just use what's required. The more you put in, the more scars you make, the harder it is to disguise them. And obviously record everything you're going to do. Now, for those of you who haven't seen masonry reinforcement, here's three very simple slides. Top left is a chap with something called a Hilti wall chaser. It was a piece of kit designed for electricians and plumbers to be able to chase into walls, existing walls, for putting cabling in and that sort of thing. But it's the most incredibly versatile and powerful bit of kit. And it will take out slivers of, well, brickwork if you want it to go into the brickwork, but generally we try and take out the mortar. So you can set the blades, two blades, set a specific distance apart, and you can set the depth up to 45 millimeters depth to take out exactly what it is you want. And the other great thing is their vacuum recovery. So you don't get those clouds of dust you see some people with angle grinders taking it out. That guy's actually working on that. That is a working bit of kit. So they're great. We've got the chap down below. He's actually putting in a bit of stainless steel rebar. Now, that isn't actually helibar. You'll see helibar a bit later on. That isn't helibar, but it is stainless steel ribbed bar, and we use that mainly in bridges actually. But if you're doing some really serious beaming, 4 or 6 mil ribbed bar is fantastic. And then the guy in the yellow high vis, that actually is the general manager of Helifix, John Heseltine, who is pretending to gun some helibond, which is a specific type of grout that surrounds the bar and bonds it into the brickwork. The beauty of it is it remains slightly flexible. So heritage people absolutely love it because it behaves very like lime mortar, but it keeps its bond. So finding the best solution to the problem, I think that's what, certainly as engineers and often surveyors, you're tasked with doing. How are we going to fix this thing? What is the best way of doing it? Don't be afraid to use innovation. That's the point. Quite often we see people just stitch bricks back together with bricks. There's a weakness there. You've got to overcome that. So don't be afraid to introduce some masonry reinforcement. If you've got a listed building, bring in the conservation officer really early. Just say, look, here's the problem. We're thinking of doing this. Do you have any comments? He will never say, oh, I wouldn't do it that way. I think you should do it this way. He will just say, you're not doing that. Well, what are we going to do then? Well, that's up to you. But that's really where you bring him in, and he or she will actually start to get involved in the project. And the more delicate that structure is and important, the more they will get involved. Bring up the pros and cons of using this or that or doing something more traditional, and he will actually see, or he or she will actually see, that there are benefits from using new materials, and you'll see this as we go on. So let's look at something very, very simple, but really important because we come across this an awful lot. 1938, semi-D, very typical. We see these all over the country. Settlement of the left-hand flank wall there due to washout. That drain pipe was actually never connected since 1938 to a drain, and so neither was the one at the back. So generally there's been a bit of washout over time and the flank wall has dropped. Brickwork's cracked and obviously the render with it. Now that's rough cast render. Not a problem. It's well bonded to the brickwork. You can run chases through that and put the helibar into the brickwork. Not a problem. Until you come to repair that render. You will never, ever, ever hide that line that you've just chased in. It will always show up. No, literally, no matter what artists you bring in to bring the textures up, there will always be at some point of light a line there. So we've scarred the building. So think about it. So what do we do? Well, you go inside. So yes, okay, the owner might not be too happy about that, but when you explain why, that you can actually do all the repairs, you can strengthen that brickwork, repair the plaster, redecorate, and they'll never know there's ever been anything done to it. And yet the wall itself has actually got the additional strength it needs to bridge that crack again. And should there be any minor movements in the future, it will dissipate those loads over that weakened area. You resin inject, replaster, redecorate, and everything's good. Now, when you then go outside, all you need to do to that crack is fill it, just very, very carefully. And then that's where you use some of your artistic skills, using pebbles of roughly the same size along and around the crack. And then you literally sponge that in before decorating it. It's not invisible, but not that easy to see. And in fact, I pass this house actually on a regular basis, probably once or twice a week, and you see it in different lights, and it is very difficult to actually see it. So let's move on to a listed building. This is out in Oxfordshire, a place called Haddenham. It's an old pub. It was bought up by a private individual who wants to turn it into a dwelling. It's listed. You therefore got a conservation officer involved. All sorts of problems right from the start. We were called in by the main contractor, who we do quite a lot of work for, and they said, we've looked at this gable wall. You can see the one with the chimney there, and it's waving in the breeze, and we want to take it down and put it back up. but the conservation officer doesn't want us to. Can you save it? So of course we went in, had a look at it, gave it a good tap, took some plaster and render off on the inside just to have a look at what we'd got, and we decided we could. And you can see it's not in very good condition. You can see that the chimney, presumably it had fires in it, it's expanded. You get the crystals forming in the cracks, and as they grow, it pushes the chimney out. We found it had debonded at one corner, or had never been bonded, and I'll show you that in a minute. Could we save it? Well, yes, was the answer, at a fraction of the cost of dropping it, rebuilding it, and against the local authority conservation officer's will. So the client saved money, saved on program, and we kept the conservation officer happy. So let's have a look at what it looked like inside when we took some of the render off. That gable wall is that brickwork you see on the left. And that was, it obviously got a flue in it, not that well bonded, had fires, all sorts of issues. It really was a stack of bricks floating about. And at that corner with the stonework, which is the left flank wall, there was never any bond put there at all when it was rebuilt. So nothing tying that in. So of course we looked at that and how to tie it in. Whilst we were there, we were asked to see if we could help with that opening you can see under the window, because they wanted to put a bigger beam in, open that out. That did two things. One, it obviously weakened the stonework above it, and it then threw more load onto the corner. So we underpinned the corner, we helibarred across under that window, which meant they could put far less propping in it, very light propping, easy to put a beam in, job done, not a problem. So let's get on to how you record what it is that you're going to do. Mostly we'll do this on CAD, but this one was done on an architect's drawing for speed at the time. But really you record exactly what's going to go in. Local authority can have a say in it, and everybody knows where the bar is for going forward. Now that's it in plan. So what we actually see top right-hand corner is that discontinuity between the gable wall and the flank wall. We come across this quite often. You'll find a spine wall in a house has got a gap between it, that and say a front wall or a back wall of a property, or a flank wall. You get expansion, contraction, and walls tend to bow out. And if they're not tied in, there's nothing to restrain that. What are the standard details we come across all the time, which is a complete mistake, is that people run the bar round the inside of the corner. Now, if the wall is wanting to move outwards, or one of the walls is wanting to move outwards, all it needs to do then is just pull the helibar out sideways from the bed joint. And that's not where the strength is. The strength is in tension. So actually what you do is you drill a hole through and return the bar on the outside, and then you are mobilizing the full tensile capacity of the bar. We've actually persuaded Helifix to make that a standard detail now. So here we go. So we've got all that wall chasing, and the beauty of the wall chasing is that you can remove very neatly the mortar in the joints. But you'll see here we've got stonework, and the joint cannot be in a straight line. Remember us talking about hiding joints. If we cut that straight, which would be the easiest thing for us to do, it would just nip off bits of stonework and you'd end up with a lovely straight line. Once that's repointed, it will stand out like a straight line as opposed to all the slightly irregular stonework around it. So in fact, we take out the mortar along the line, the bed joint, the uneven bed joint line. Pop the bar in, because the bar will nicely sort of undulate around that. Pop the grout in, grout it well into position, and when it's repointed, you won't be able to see where that's been. The point I put on this right-hand photo, or the point I want to make on this right-hand photo, is if you're involved in masonry reinforcement, then the quality of the installation is absolutely critical. Because let's, for instance, you nipped a bit. We've seen this done many times by others. You nip a bit of the mortar out. You got the bar. You stick it in, and you put some grout in. Well, all that's going to bond the bar to the brickwork, which is the important thing, is the mortar that you've left in, the old friable mortar. So you'll have no bond strength. There'll be no transfer of load. You might as well just use duct tape. So the important thing is to remove the depth you need to. So if you're going in a single bar, it'll probably be at least 20 millimeters into the bed joint, and make sure you've removed brick to brick. So you are actually going to bond to the brick. You then vacuum out that slot, you wash it out, you prime it, you pop the bar in, or you put your first bead of grout in, pop the bar in, and then grout over the top, leaving 15 millimeters back for the pointing that goes on the top. Again, you've probably seen these guys a number of times, 5 millimeters of repointing over the top. Of course, what happens within a couple of years, it starts falling out. You need it 2 to 1, basically. So it's a 10 mil joint. Ideal 20 mil, but generally it's always accepted as about 12 to 14 millimeters of depth. But that's the important thing. You see the chases on the inside there. We didn't take them round the corner. That was a bit deceptive, and I actually wanted the guys to offset those 2 lines. But in fact, from that flank wall on the right, the bars run right through to the outside and round. And what we use on the inside of that brickwork is a series of reinforcing bars to stiffen that wall. Because remember, it's floating, it's running over the flue on the inside, and basically it ties everything together and gives that wall some stiffness. So those are some of the techniques that we use for masonry reinforcement. And that can be in old buildings or new. You've just got to be a little bit more care in old buildings. Now, here's a structure that a lot of you have probably been to and seen, gone past, may have been invited to sort of highfalutin celebrity balls and things there. But we are looking at part of the Brighton Royal Pavilion and the Adelaide balcony. And the Adelaide balcony sits at first floor level, just outside the restaurant cafe. It's also used, obviously, as a dining room, and for functions like receptions and weddings and things like that. So you can end up with a couple of hundred people jumping around on that balcony. Bit of history for you before we go into to more of the science. Royal Pavilion. George IV commissioned John Nash, that famous architect, to design him something spectacular. He wanted to show off to lots of foreign dignitaries, and the site was an old villa, and he wanted something much more impressive. Nash at the time had found that he'd seen cast iron used in various places and realized its benefits: larger spans, slender columns, giving you much more scope for sort of architectural expression. Nash also did these sorts of buildings too, you'll know. But again, probably as you guys know, the cast iron has a problem, and that is that it's brittle. So it does a fantastic job until the point it doesn't, and it will suddenly shear. And of course, that is one of the issues. But the revolutionary, the revolution back in the late 1700s was for use of this cast iron, and it was used for the first time in an industrial building by William Strutt at the Flax Mill, and you can go and see this as a museum, and you'll get that. You immediately see from that photograph that open space, solid floors, slender columns, beams with jack brick arches, making everything very solid, relatively fireproof as well. Obviously, you've got mills, lots of dust. Very, very useful structure. But as we said, it breaks. And what happened in early 2000s, as you can see here, reported in the NCE, was that a roof had collapsed at a property in Bayswater, and it was a cast iron trussed roof. So it sent a bit of a ripple through the historic building market. Those who've got historic buildings to say, are we in danger of the same sort of thing happening? So engineers investigated, and onward went through other buildings and properties looking at the problem. Why is this a problem? Well, let's look at the manufacturing of cast iron. To actually form, you melt down a composite, an iron composite, and presumably you get as many impurities out of it as you can. But to cast it, you use sandpits in the shape of the member that you're looking for, in this case, a T section. So the T is always at the top. You pour in the molten cast iron, and as it is still in molten state, gas bubbles are rising to the top, and they bring impurities with them. So you'll tend to find that the flange has the more variable quality of cast iron in it, and that's where the impurities are. Unfortunately, when you turn it over to use it in its structural form, that's where the weakness is, and the unpredictability. So Brighton Royal Pavilion, the trustees suddenly realised they potentially had a problem because they've got cast iron throughout the building, and particularly on the Adelaide balcony, where there was a lot of support required with fairly big spans beams. They called up John Holden Associates, who'd been involved in the Bayswater collapse, and they came, did some testing, did some analysis, and realised actually that the beams were, or the cast iron was of poor quality, and something had to be done about it. So the first thing that the trustees did was to put up some propping, and that stayed there for a few years, halving the span, reducing the risk. It meant they could keep the cafe open, keeping the revenue coming in, keep using the balcony, but that's not a long-term solution. At that point, because we'd done quite a lot of work for Brighton Council and some of their listed buildings down there, they called us in and said, is there something you think you might be able to do with this balcony? So obviously do nothing. Risk of collapse will mean you can't use that balcony anymore. It's not going to probably collapse under its own weight, but if you're going to use it, jump about on it, it likely is. Install some secondary beams. Obviously, you've seen what those props look like. It would look a little bit like that, probably slightly more elegant, but not much. And if you've got a grade 1 triple star gold building, as you have with the Brighton Royal Pavilion, then it's unacceptable to have anything that doesn't look original. So maybe, this is where I should have got this little beauty down. Maybe we can use carbon fiber plate. We use it a lot in strengthening reinforced concrete beams and slabs. Ideal, light, thin, wicked. What a great idea. until we started to look into cast iron and the coefficient of thermal expansion. Doesn't really work very well with carbon fiber. So, and the reason being that if you think about how stiff cast iron is and how generally ductile steel is, they're two completely different things. And to get the bond strength to make this work for the cast iron, you'd have to shrink the cast iron down, bond this to the surface, allow then the cast iron to expand, putting that under tension and taking load away from the cast iron beam. But the problem is if you reduce the temperature down to where you need it with cast iron, the glue, the adhesive that you use to bond this to the cast iron, it would never cure until you got up to a temperature where the cast iron had expanded again, and really you'd have just stuck that to the underside of it. Wouldn't do any good. It's no good in shear, so when that cast iron shears, that's no good because it would just debond. So we got to think again, and we came across a method of using carbon fiber fabric, but you don't use it on the beam, you use it on the brickwork. So just a little bit on carbon fiber for those of you who don't know. Airplanes, boats, racing cars are made of a carbon fiber sheet, so a fabric which is woven in both directions, okay, because the strains obviously come from all directions. Carbon fiber plate and the sheet that we want to use, we want to bring into play all the bond in one direction. So you want them in one direction. So it's unidirectional sheet. It has to be bonded together with something, so it has a loose weave over it to stop it completely falling apart. But in essence, it is just a sheet of carbon fiber elements, about 0.3 of a millimeter thick, which is then bonded to a surface. Our engineers that we use, our heritage engineers, CTP, used the principles of a design previously carried out by Colin I can't remember the name of the other people who did it, but they basically took that theory and expanded it into the jack arches here for the Royal Pavilion. And you can see there that we end up wanting to bond 200 millimeter wide strips all the way across the jack arches from side to side to strengthen it. And what that will do, as you know, with jack arches is that they actually spread the load from the slab above circumferentially around and into the beams. We want to take some load off those beams. So we want that brickwork to actually span longitudinally or laterally from wall to outside column. And that will then reduce the load that goes on to the cast iron beams. So all the sums worked, including the costs that were accepted by the pavilion, and off we went. Now, when you're working on listed building, its protection is like everything. I mean, you literally can't put enough protection around it. This all had to be fireproofed as well, because just behind those props is the King's Apartments, and they are full of priceless carpets, ornaments, jewelry, you name it, it's in there. So that all had to be very, very carefully looked after, and they're paranoid about dust. So we encapsulated that whole thing. The hoarding up, and we had ourselves a very nice working environment inside. So control temperature, we can control the dust, and work, very, very closely with that jacquard soffit, which you can see there. all the sheeting is fireproof. As we said before, when you're on a listed builder, you need to log absolutely everything. So every beam got a number, every jack arch got a number. And as we went through, we recorded everything we found, and we recorded everything we did to that particular beam, jack arch, whatever it was. And that is one of the stipulations of working on listed buildings. So the next thing to do was to take that render coating away from the brickwork of the jack arches, of the brick jack arches. But when you're working on listed buildings, the historic side of the rules will tell you that you must not take more away than you absolutely have to. So we were only allowed to take a certain amount of render off, and that had to be the width to which we needed to put carbon fiber strips on, about 200 mil wide. See the Hilti wall chaser again, because we can get accurate depth, vacuum recovery, absolutely ideal bit of kit to put the cuts in so that we can then take away the render. But as you can see there, more render fell off than just the bits that we wanted. Nothing we can do about that. It's debonded render. It can't stay there anyway because it could in the future fall off. So there we'd expose the cast iron beams, which at some point we think in the last 30 years had been painted, and probably that render renewed. But you can see there we've got jack arches, but then we've got bits of stonework just running into the cast iron beams. And we think that's just literally so that you get a very tight fit, because the bricks wouldn't have been exactly the right size. There we are. So all the render that's going to come off did, and we're then in the cleanup situation. So we've got to clean up that brickwork, make sure it's ready for bonding. And the bonding is everything, because if you don't get a good bond to that brickwork, like I've said before, you might as well use duct tape. So we want to mobilize the bond between the brickwork and the carbon fiber, and that is essential. For those of you who don't know, to mobilize, even in carbon fiber plate like this, to mobilize the full strength of that, which is 10 times stronger than equivalent steel, you need 1.25 newtons per millimeter squared of bond. And that is enough to fully mobilize the strength of the carbon fiber. So you do these tests, and if for those of you who haven't seen, you bond these 50 mil diameter dollies to either concrete, in this case brickwork obviously, and then when the adhesive is cured, you pull them off at normal to the surface, and what you hopefully do is debond part of the brickwork. You want to see what that bond strength of the brickwork is, not the adhesive to the brickwork. It's actually hopefully pulling a little bit of brickwork away. Obviously, if it bonds well enough and the adhesive comes away from the brickwork and you've reached in excess of 1.25 newtons per millimeter squared, you've got no problems anyway. So this is part of the quality control. What we also did was jack a little bit of load out of the beams. Now they're not flexible like steel beams, so we've got to be very careful, and we actually put 8 kilonewtons of load into each of those props and maintained that throughout the installation of the carbon fiber. That's Annie. She is our actually conservation manager, and got involved in the project to make sure that everything went according to plan. That obviously just relieved a bit of load and lifted the balcony very slightly, which helps when you put the load back in. Carbon fiber sheet, lovely working environment. We have to slice these rolls up because they happen to come in 1/2 meter wide rolls, easy to cut, and you get all your layers ready. So you've cleaned the brickwork, that's not the end of it, because actually what happens is when you look at that brickwork closely, the bricks are in slightly different alignment. There's a bit of mortar coming out between them, so you will end up with actually quite an uneven surface. And when you're bonding carbon fiber sheet to that, any gap that isn't bonded to the brickwork because it bridges, you're not actually mobilizing the strength of the carbon fiber. So we want 100% of that brickwork in contact with the carbon fiber. So you put up a primer coat, you then put up a regulating coat. Yeah, it's all quite painful, this. For those of you who've tried plastering, it's difficult enough with plaster. Try doing it with a thixotropic epoxy mortar, which John is doing here. He's worked for us for over 25 years now. Master screeder, master plasterer, made it look very easy. But you end up with a completely smooth, regular surface, which is fully bonded to the brickwork, onto which you then put the carbon fiber sheet. And here we go. So we put it up in layers. Now you'll see when you add up 9, 9 and 3, that's 21 layers of carbon fiber sheet. Why we didn't put it up in 7, 7 and 7, I've got absolutely no idea, but that's what came out. So the reason you don't put all 21 on at once is that you are relying on the bond between that first sheet and the regulating coat. And if all the other sheets that you put on after that drag that one coat off, then you might as well have used duct tape. So you don't put too much weight at any one time and you allow it to bond. So you do it in sections, do 9, move on to the next one, do 9, do on to the next one, then come back, do another 9, then another 3. And to ensure that you get full encapsulation of the carbon fiber elements, you use a rubber squeegee, and every time you put resin up, you squeegee it through and you push that carbon fiber sheet up to the one above it. And there we are, all in place. So the next thing to do, you've got the strengthening. That's it now. You've strengthened the jack arches. They will help take load away from the cast iron beams. It's now to put the render back. Now, we talked about the render falling off, and at some point in time, 30 or 40 years ago, it had been repaired or replaced. They hadn't done it with lime mortar. They'd actually done it with a render, a sand and cement render, which we were really surprised about. And because it's a heritage building, you actually have to match what's there at the time. So in fact, we ended up putting back a sand and cement render. We were allowed to add some SBR, which gave it the it handles better and it's stickier and it will bond better. There we are, scratch coat. And that's it, all applied by hand, finished. So when you go down to the Royal Pavilion at Brighton, and you go and either go on top of the balcony or walk underneath it like that, you will now know that it's all been held up with carbon fiber. Very happy client, and all in full service. We do heritage works all around the UK. And this one is on the Isle of Wight. So we're changing now from carbon fiber to masonry reinforcement again. This is a beautiful abbey on the Isle of Wight called Quar Abbey, Quarr. Well worth a visit if you're down there. Yeah, it's quite extraordinary. Benedictine monks, turn of the century, came over from France. Obviously got this plot of land, and whether I don't even know it was a French architect or not, but this was built. It's beautiful, and has been absolutely fine until recent years when cracks started appearing in the arches. We do quite a lot of work on the Isle of Wight as well, and we were called in to see what we could do to reduce the risk of masonry falling out of those arches, because they use that area for prayer every day and the public has access to it too. So if they lose the public going in from danger of falling masonry, they lose very important revenue. So we were asked to go and analyze it, have a look at it, see what we could do. And we came up with a series of plates and masonry reinforcement to ensure that the brickwork stayed where it was. Stunning. 12-meter tall towers. We couldn't put full scaffold up because it would have stopped use of the main aisle. And so we had to work off tall scaffolds. But you can even see in the crypt downstairs the sorts of damage that we were finding. And so what we needed to do in some circumstances was do a little bit of rebuild of the arch, but we incorporated masonry reinforcement into it to ensure that it could crack if it needed to, but nothing would fall out. And that's it. Flattened image, but well worth a visit. The movement is ongoing and is part of something we're investigating at the moment to do with foundation and bearing capacity. Why it's suddenly started now, we really don't know. Right, over to Bath. For those of you who've been to the Royal Baths, this will be familiar or know Bath very well. York Street goes down through and under that arch, and picture to the right is a Swallow Street coming up to it, and you will see the cathedral in the background there. Those two ladies walking. That wall there below with the balusters in is actually the edge of the Royal Bath. So if you jumped up onto that wall, you would look a story down into the main museum open bath, which is fed by hot springs. So that's our location. York Street, however, is not original in terms of, it's not Roman original, it's actually a Victorian invention. They wanted to lift a lot of Bath up almost a story up to the level you see it now, and so they've built York Street on a series of composite beams. So if you can imagine the Victorians, so yeah, it's been there over 100 years, things are bound to happen. So there we are down below. You can see those composite beams in grey, and they are supported on bits of, well, the Victorians used anything they could find. So bits of cathedral, anything, and they built a series of support walls on concrete jack arches. So there we see the length of York Street that is supported, and you can see that those beams are all different lengths, slightly different orientations, absolute nightmare. And the composite beams are made up of two steel I-beams side by side, butted together, surrounded with concrete. And the problem was they didn't grout up between the two steel beams, which means obviously you're in the areas of high humidity because of the springs, relatively warm temperatures as well because they're hot springs, with a slight sulfurous component to them. Absolute nightmare for corrosion. So wherever they were slightly exposed, which tend to be the ends, that's where the corrosion was occurring. And the factor of safety on York Street could not be guaranteed. Therefore, it was limited in weight, which means delivery lorries can't get to the high street, all sorts of bits and pieces. And they had to come up with a solution for strengthening or replacing those beams. So we looked at it on the practical side of things, and came up with a suitable solution. This is the sort of thing you've got to get over. What you're looking down on there is the old Roman pavement, which is covered in sand for protection. But basically, archaeologists are paranoid about anybody walking on that, let alone working on it. They are bits of abbey were used in the walls. But we managed to work with the archaeologists and conservation officers to have a method of working with a scaffolding on the Roman pavement, supported on the Roman pavement, that was acceptable. And off we went, looking at it, surveying it, and that's our working environment. So you can see the Victorian concrete there, bit honeycombed, tested, absolutely perfect, not a problem with it. But the beams were starting to corrode at the ends. We took some of the concrete off over one of the center piers just to get an idea of how far this corrosion had gone. And in fact, we found it really wasn't bad. It was, yes, it was rusted, but it wasn't flaking in any way. And you will see that in a minute. So the solutions that we came up with alongside the consultants called Rexon Day was to encapsulate the composite beam with two steel angles, galvanized steel angles bolted through. Now they were designed to take the full weight of York Street, so that should in the future anything happen to the Victorian composite beams, they wouldn't be relied on. Okay, so the new scheme we're putting in will do the job for the foreseeable future, all galvanized, so it should last well. So each and every beam was surveyed, measured, and as I said before, they were all different lengths. So we had to make templates up for every single beam so that we could get the drill points in exactly the right place. The templates, a carbon copy set was sent over to the fabricators so that they would drill their holes in exactly the same places, galvanize them so that you've got corrosion security at the holes. And when we bring these things back to site, they will fit because that's where we've drilled the holes. So off we went, coring. Now you can imagine the corers quite happy coring concrete, but they then had to core steel and then avoid and then steel and then more concrete. So it wasn't quick. And there were 1,500 holes that we had to do in exactly the right positions because the tolerances were fairly tight. And there's the lads working there. We got dispensation for not wearing hard hats. We did generally wear bump caps, but in essence, yeah, that was all right. You can see the marks there. We cored the steel and took samples in regular places. And you can actually see there that steel is in pretty damn good condition. A little bit of rusting on the outside, but apart from that, fine. And nearly 17mm thickness of steel in the web. Now we're going to be putting steel C-sections up against that concrete. What we found was that the concrete sides were like this all over the place. So we had to regularize those by applying a mortar to the size of it, a structural mortar, so that the two C-sections would be normal to each other. We monitored for vibrational part of the heritage side of it, and there we are, just applying the 40 Newton high build bare concrete. Now, why are we doing it with steel like that? Couldn't we just take out the old beams and put new beams in? Well, one of the problems was that the only access to that area was through a manhole in the street. We couldn't come in through the museum because again, just too tortuous. We couldn't come in through, shall we call it a tradesman's entrance, because it was like It was like a maze, and you couldn't even get a sheet of ply through there. So this was the only access. So everything had to be designed to be lowered in into the basement in 3 sections, as you can see. So each beam came in 3. And we could erect that then relatively easily. There, we had special little scissor lifts designed so that we could lift them without having to strain the guys, lift them in position, maneuver them so we get the bolts through, and then dry pack to the top of the columns and the jack arch on the top there too. So it went relatively well. A lot of planning had been done, but it went relatively well. But we decided and persuaded the archaeologists that they should grout up that annulus. Sorry, not the annulus, the void between the 2 steel beams to reduce corrosion going forward. And they agreed to it. And so we actually already had some holes drilled in, ready for them to be able to do that. So we can flood from one end to the other and grout up that annulus, hopefully slow down the corrosion. But of course, the archaeologists were paranoid about spilling grout on their Roman pavement. So it was protected with paddling pools and buckets and visqueen and all sorts of things like that. But at the end of the day, all in position, and York Street is back open to 44-ton trucks and supported. And it is now, that area below is now part of the museum. So you can actually go down there and see various Roman antiquities. You can go down, I think schools go down there doing various bits and pieces like that. So it is part of the museum now. And there's even an area where the kids can go and scrabble around in the sand and find faux antiquities. So that was great fun. Now, just briefly, changing on to arch structures. We were called in by insurers, and I mentioned that we do a lot of insurance work. And this is up on the northwest of England, a place called Ramsbottom. It's a culvert, and it runs under the road. You can see just ahead of you there, that sort of white curved face of the culvert. That is under the road section. The section this way, which you can see is collapsing, is in this chap's garden. So he is the client. And when we went to site, he said, "Yeah, come in, have a look. There's a massive void to my right." So we said, "No, thanks." So we put on a long pole, we put a GoPro up there and had got a video of what's what, because the back wall of a 3-story stone mill, half-meter thick walls, is sitting right over the top of his head. So it actually sits on the crown of the culvert, and he's walking in there. So anyway, what can we do? So over time, the stream that the culvert takes, with the sorts of floods I think that we're getting nowadays, huge volumes, huge energy, has caused scour. It's washed out some of the bottom of the abutments, and therefore you've got progressive collapse. But there were cracks in the house, but that was it. It all maintained itself relatively well. So that gives you an idea in cross section of the void that had been formed under his house. That was under his lounge floor. It was, you could get a mini club and estate up there without any problem at all. And the back wall was now sitting on the culvert. You can't see the culvert there, but that's where it is. So we had to find a safe system of work, and this is again, you just using common sense but innovation. We do a lot of supporting of masonry arches in our bridge business in temporary conditions, and we wanted a safe system of work here. So we looked at creating stable foundation with high strength rapid set concrete bags, onto which then you put maybe props, with semicircular sort of ribs and some mesh to hold it up, and then you work your way in one a day so that you've got protection. Because there you can see the amount of collapse that there's been. This went through temporary works, obviously, design check, and was given approval. And we tied the house front to back so that obviously the back wall part of it is floating away over this culvert. And we wanted to make sure that if it tried to move, at least it would be tied to the rest of the house and it would resist and spread some of the load. We dynamically monitored it because at any one point in time, we didn't know whether there'd be a shift. We have to take some more stonework out to be able to then get things ready and put it back. We don't know what that's going to cause in terms of things. So we dynamically monitored the building. So at any one point in time, an alarm would go if there was any shift to any of those targets. We also spread the load of that back wall. So the culvert, as you were looking into it on that other photograph, goes from that left-hand sort of garden wall that you can see there, the other side of which is the road, and the local authority culvert then takes over under that, right to where you see that guy in the centre in the orange high-vis leaning over the C-section. That's at the point where the culvert comes out and runs alongside the remainder part of the house. So we bolted this into a half-metre thick wall so that if you got any one bit of collapse, at least hopefully that beam would help span that back wall. And there we have it in position. Very tight working. We obviously used as much of the existing stonework as we could and started to rebuild it. Now you see bits of good old helibar. Again, used to assist in tying things together in the temperature condition whilst the mortars cure. You see we use wedging, we use a wedging technique because you need to build some compression into the arch and then dry pack the joints to make sure that you've got some load bearing capacity in the arch. From word go, we actually concreted the bottom of the abutments in as well to give them some resistance to scour. And that's it completed. We did over pump, as you can see, but it didn't. We couldn't get rid of enough of the water, it was again that lateral thinking, because basically the insurance company were going to decant the client, put him in a hotel, knock down most of his house. You'd have to shut the road because it was right on the corner of the road, and then rebuild it. We did that for £250,000. It saved the insurance company an absolute fortune. I'm not sure the client was too happy, but it was, again, just using, lateral thinking to solve a problem. I think I've rabbited on about that probably most of the way through. So I'm hoping that was useful. It was about an hour, maybe just a bit over. I don't know if Matt said at the beginning that really happy with questions.
Extra part, but if I've got to go down there on Monday, so we're doing some trials down there on Monday.
So if you've got any Matt maybe didn't say at the beginning, but if you've got questions, if you've been writing them down, brilliant. He'll start to read those out. If you've got actual verbal questions now, please go ahead. We'd love to hear them.
Nothing in the chat at the moment, Dave. So if anyone just wants to raise their hand, and I'll just kind of go through you guys one by one and ask any questions that you might have, just off the back of what you've just seen.
And also, if we can have any sort of feedback on improvements that we can make to that, what's boring, what is of absolutely no interest at all to you. We always try and keep improving these things and making them more interesting, more useful if we possibly can.
We've got a few that are flying in now in the chat. I'll just go through these quickly, David. You can answer. So, Lewis, do you act as main contractor? In the first question.
Yes, we do. We have main contractor status, and we can take on anything. I think the biggest project we probably had today is about $1.5 million, but that was a highways project on a bridge. So we can go from that right down to being specialist subcontractor, but probably we act as main contractor on the majority of our jobs.
Brilliant. Then got another one. Do your design in-house?
Yes, we do. Not for everything, but we have our own in-house design department, and so we can do everything from carbon fibre strengthening through what you see generally there as the design for structural repairs, but we also do surveys, structural surveys. So yeah, we go out, look at a building, and if it's going to be altered, the client then got an idea of what he's going to need to do to it to alter it.
Brilliant. Let's go through these again. Do you cover properties throughout the south, which you've answered? We kind of location wise.
We do. I mean, if you can think about it, it's being cost effective. So for the more unusual jobs, you can travel around the country. Guys are going to have to stay in hotels. We don't have guys in all over the country. It's being cost effective. So it's a fairly simple structural repair job. There's no point in us going to Cornwall because you'll get a local contractor to do it much cheaper. So it's being cost effective. It's being
Brilliant. I'll just work through a few more of these. A lot of these are asking for presentations, recordings. Guys, I will issue these after the session, so you've got a copy of them. That's not a problem. Esme has asked, was the final building with the culvert temporarily decanted and propped once the issue was identified, and how long until the repairs were completed?
good questions. Part of the house was evacuated, or suggested it was evacuated by the client. He didn't move out. He refused. And that project took 6 weeks. Once it was up and running.
Brilliant. Stephen Horton, he said, I have a street vault which is in a poor state with the same solution for repair work as the last project shown, which you've just mentioned then.
Stephen, wasn't that name Stephen?
Yeah, Stephen was correct.
Stephen, yeah. Vaults, we've got a couple of case histories we might be able to link with you where we've repaired and strengthened fractured vaults under London streets. It depends what you need to do to it. So once it's analysed, can it take the load or above it? If it can't, then obviously it's going to need to be strengthened. It might just be crack repairs. We realised when we analysed that culvert that in fact, if it was rebuilt, it would do the job it's been doing for a couple of 100 years. For vaults, sometimes the load above, as we now know, sort of street loading is a lot higher than it ever used to be. We got up to 44 tonners using the streets. Sometimes these vaults now can't take it, and therefore they need strengthening. So in which case, yeah, we bring in our mast system and we use the masonry reinforcement within the vault to do it. And we've done it in a number of places in London to bolster the load carrying capacity of the pavement, because you get accidental loading of pavements. You get some quite large cranes coming in, pad things, that sort of thing. So in fact, vaults suddenly come under a lot more strain than they ever used to.
Thanks for that, Dave. Steve, if you want to drop either me or Dave an email with that project that you're referring to, we can take a closer look. Just moving on to a few more questions quickly, Dave. Last few. Do you get involved in surveying and repairing existing reinforced concrete structures, or those working in composite action with steelwork frames?
Probably specifically not composite structures, but inevitably you get involved in something. You will go to a building where there's concrete repairs required, yeah, and it's abutting an existing brick structure or part of a steel structure. We don't do any analysis on that, or we haven't up until this point in time, but we would give advice on methods of repair for concrete, and if necessary, carry those out. So in other words, if we're doing some structural repairs for other things and there's some obvious concrete repairs required, we're very cost effective to do that, we can. But if you gave us a block of flats that had, you know, a couple of thousand concrete repairs all over it, plus they were going to reclad it and all the other bits and pieces, you'd be much better getting a concrete repair company to come in. They would do it far more cost effectively than we could. We can do it just to the same standards, but not as cheaply.
Brilliant. Thanks, Dave. I think someone else asked similar questions to that. Probably answers two of them in one. Did have another one which asks, does temporary propping of masonry arches tamper the compression within the arches?
Absolutely cracking question. Yes, it does. So what we were doing at that culvert that you saw was yes, it was propped, but what we weren't putting is load into the arch, because you're absolutely right. If you prop an arch, arches flex when you get, particularly in a bridge, you get load going over it, the arches deflect. If you then prop that arch, it can't deflect, so it can't distribute load around it. And so you will start to get cracking around that point. We do, however, do multi-prop arch protection, but again, usually leaving a little gasket at the top that's compressive. If the arch has got to stay in use, it allows the arch to just deflect, but stops any catastrophic collapse. But great question.
Brilliant. Thanks, Dave. I think that's most of them in there. So unless anyone did have any last minute questions, feel free now to speak your piece or put them in the chat. We can get back to it later today. But there seems to be some good feedback in the chat. So if there isn't any more, thank you everyone for joining.
Well, wonderful. Yes. Yeah, as Matt said, thank you very much for joining. If you do, if things occur to you, you suddenly get a project, you've got our details, just give us a shout. We're more than happy to try and help or advise. Yeah, that's what we're here for. So many thanks again. Enjoy the rest of the week. I hope the weekend's going to be nice and sunny for us, and hope to speak to you, all of you, really, at some point in the future.
Brilliant. And just to add as well, guys, I know quite a few of you signed up for our ground stabilisation seminar next Monday. If those of you who haven't been to join, just drop me a message and I'll send you the invites for that, and hopefully we'll see you then.
Take care till then. All the best. Bye-bye.
Thanks, guys.
Cheers.
We can't confirm what's going on there, but yeah, if he's got a chance, I'll be